Hello, it's Dr. Mike here again with another medical 3D printing video, and today we're going to go over methods of creating medical 3D printable models using both free online services as well as free software packages that you can install on your desktop. And we'll be making this model, which is a head and neck artery, vein, and bone model from a medical CT scan. So without further ado, let's get into it. If you haven't already, please download the associated file pack, which will allow you to follow along with this tutorial. The download is free, and there'll be a link below in the description. So go ahead and do that so that you can follow along and get the most out of this video. So let's start off with going over some of the things that we'll be talking about. We'll use the free online service on embodied.com, and then alternatively we'll do the same thing using Slicer and Meshmixer, and I'll show you the benefits and differences between these two different methods of creating 3D printable models. So we'll start off by opening the file pack, and we'll use this data set called the Mannix data set, which is an anonymized data set. And what we're going to do is open Slicer, which is a free software program. If you don't have it, you can download it from slicer.com, and take the Mannix angioct.nrrd file and open it in Slicer by dragging and dropping. So click OK, and Slicer will open this up. So this is the CT scan that we're going to base our 3D model on, and you can see that there's contrast in this scan, and it's including the skull and most of the neck and some of the upper chest. Now, the first thing we're going to do is take that same file, this angioct.nrrd file, and we'll upload it to Embodied, and we'll let Embodied process this automatically while we are going through the desktop software programs. So if you go to www.embodied.com, and if you don't have an account, you need to register. Registration takes just about a minute or so, and it's free. And click on the Imaged tab and Launch Imaged. And make sure you're logged into your account, and take that NRRD file. And I should mention that the service only takes NRRD files of CAT scans, so CT scans. So if you have an MRI, it's not going to work. You have to have a CT scan like we have here, and drag and drop that NRRD file. If you don't know how to create an NRRD file from a typical medical imaging data set, there's another tutorial that I've done on how to make that conversion. It's really easy. You can do it with Slicer, but look for that. I'll put that in the link below as well. Okay, so our file is uploading. Now I'm going to be giving this very same tutorial at the upcoming Radiological Society of North America meeting, which is called RSNA, at the end of November. It's the biggest radiology meeting in the world, and I'm actually going to be giving 4 workshops on how to use free and open source software and services to create medical 3D printable models. So we'll be, if you're going to be attending the meeting, we'll do the exact same workflow during those workshops. And if you're looking at this video and you've attended the workshops and are looking at this video afterwards, this is going to be the same thing that we covered in the workshops. So for the name of this file, I'm going to call this RSNA, because that's the name of the meeting, tutorial, and we'll do this medium, let's see, intro, medium quality. And I'll put a little something in the description, head and neck model from CT with contrast. And the NRRD file that we're uploading, we are going to keep that private. We have to specify a license type, but that doesn't really matter because we're not sharing it. And then we're going to turn on this processing tab. Turn that on, and we have a variety of operations to choose from. And what I'm going to do is create a detailed file. I like the detailed one because it gives me the most detail. And when you're doing anatomic modeling, that's important. But this first one is a little bit smoother and prettier. You can also generate muscle and skin. But let's keep it on detailed. Threshold, we'll leave it at the default threshold of 150. We'll set the quality to medium, and we'll make the output file private, and then I'm going to click Save and Submit. And now my file has been uploaded, and what's going to happen is the embodied service is going to process that file automatically. They have a workflow and a background software that basically just automatically creates these 3D printable models, and they will email me when the model is done, and that should be in about 10 minutes or so. But in the meantime, we will continue on with the desktop version of this of making a medical 3D printable model. I really think that the embodied service is extremely easy and very quick, and is definitely the way to go unless you're doing some kind of complex segmentation, or you're trying to do something really complicated and unusual with your model. Okay, so now we're going to minimize that, and while that's working, we'll go ahead and go through the Slicer and Meshmixer workflow. So we've opened our model in Slicer, and what I'm going to do is I want to show the 3D rendering of that in this panel. And so what we'll do is go to Volume Rendering and click this little eyeball right here that turns on the volume rendering. And it may be off the screen, so you have to click this little, I don't know, it's like a bullseye to center the rendered output. There we go. The left mouse button will allow you to rotate. The right mouse button on a Windows machine will let you zoom in. And we now are going to convert this file to an STL file format, which is the file format that most 3D printers will recognize. So now I should mention that if you don't have this layout on your version of Slicer, you can adjust that by using this layout menu over here, and you can select from a variety of different layouts that will show all of your different things. The ones that I use are 4-up. I find that to be the most helpful. Anyway, so if you want to look at your scan using the 4-up layout, that's fine. If you'd like to use something else, you can. That's fine. Now we're going to convert this to an STL file using a module over here called Grayscale Model Maker. And Slicer has a ton of these modules, and I don't even know what most of these do, but it seems to have something for everyone. And the one we want is Grayscale Model Maker. Okay, so we're going to go ahead and select that. And our options show up here. It's going to take this Angio CT input volume, and it's going to produce a model, and the model is called Annotation ROI. Let's go ahead and rename that, and we'll call this RSNA model. Okay, and we can set the threshold to about 150 because that's the same one that we used on the website. Set for decimate, let's make that 0.75. Okay, so what that means is that the output geometry is going to have lots and lots and lots of polygons, too many actually, and that'll just slow down our computer and make it very difficult to work with. That means we're going to, 0.75 means we're going to reduce the size of the output mesh by 75% so that it's a little bit easier to work with. It's still going to be very large, but that's going to help. And then we click on Apply. And Slicer will kind of churn away, and what it's doing now is it's making a surface model that we can then save in STL file format. So when you make a 3D printable model from a medical scan is a volume. You know, there's data in every voxel, which is voxel is like a three-dimensional pixel, so it's a little cube, and an STL file is a representation of a surface. So we need to change that volume into essentially a surface, and in order to do that we need to figure out, you know, where something is going to be inside the surface and where something is going to be outside the surface, and that's where this threshold value comes in. This says that everything that is more than 150 Hounsfield units, which is the units for CT scans, that's going to be inside the surface, and everything less than that is going to be outside the surface, so that will make the surface of our model. Okay, well, anyway, hope that was clear as bud. We are going to go ahead, and now that we've made that model, we're going to save it, so click Save. And you'll be given the option to save a bunch of these different things, and really all we want is this thing called RSNA model. So uncheck everything else, and it's currently going to try and save it in the VTK format, and we don't want that. We want to save it in STL. Okay, so you're going to go here and change the file format to STL, and then you also want to change the directory that you're saving that in, and we will save it in this tutorial directory. And then click Save. Alright, and I apologize if my voice is a little scratchy. I'm recovering from a cold. So now our model should be saved in our folder, and it is. So we can go ahead and close out of Slicer. And now I'm going to open this model up in Meshmixer. So you can get Meshmixer from meshmixer.com. It's free, so download it, and it works for Macintosh, Windows, and Linux. So I'm opening this model up in Meshmixer. Taking a little bit of time there. Well, I'll tell you what, in the meantime, what I can do is oh, there we go. Okay, so here's our model. And it's, you know, it looks okay, but obviously there's some problems. We've got some disconnected pieces. There's this thing, this is part of the brace that the patient was in, and this thing over here, and there's little bits of stuff all over the place, and all these red dots are errors in the mesh, so areas that need to be repaired before this thing can be 3D printed. So we got some work to do. And the first thing we're going to do is remove everything, all these little bits that are floating around, you know, that are not connected to the main part of the model. So to do that, we choose the Select button over here on the right. The right nav area has a bunch of options. These are for things you can do, and what we want to do now is use Select, and it'll give us the Select tool, and you can see that it's this big circle over here, and if you click on the left mouse button, it selects all of the faces underneath that big circle. You can change the size of the circle by using the size thing to make it a little bit smaller. So what you want to do is just select something on the head here, and then we're going to expand our selection. So we're going to expand it to include everything that is connected to this zone. Alright, and we'll do that by going to Modify, expand to connected, or you can just hit the E key. So expand to connected or hit the E key. And now you can see that everything that's highlighted in orange is currently being selected. But we have some problems. This clavicle, which is on the patient's right-sided clavicle and then part of their scapula, is not included. And the reason is that these are not actually attached bony. There are no bony attachments to the rest of the model. So we want those included as well. So I'm going to go ahead and select a little spot on there, select a little spot on there, and then repeat that thing where I go to modify and expand to connected or hit the E key, and it should grow the selected region to include those parts. Okay, now everything that I want to keep is in orange, and everything that I want to get rid of is not in orange. So what I want to do is actually reverse the stuff that's selected, and I can do that again by going to modify and selecting invert or hit the I key. Alright, and what this will do is reverse what is and isn't selected. So now the only stuff that is selected is the stuff I don't want. So I don't want any of this stuff. So I can now delete it by going to discard or hitting the X key. Alright. And this, by going through this process, we've gotten rid of a lot of the junk that is included in this file. But there are still problems. You can see that there's still large areas of red all over the place. And if you go to the bottom, you can see that there are these gaping holes in the mesh. And we can't really 3D print this because these represent defects, and the 3D printer doesn't know what to do with that, how to fill it in or what to do. So we need to clean this mesh up a lot before it's ready to be printed. So fortunately, Meshmixer has an auto repair option that doesn't always work and doesn't fix everything, but can fix most things. And so what we'll do is go to Analysis and Inspector. Okay, so you click on the Analysis button and go to Inspector. And what this will do is it will show you all the errors currently in the model, and there are a bunch of them, as you can see. Things that are red represent mesh errors, and things that are blue represent I think open edges, and so this is not really a great model at this point, so it needs to be repaired. And you click this Auto Repair All button, and what will happen is Meshmixer will attempt to automatically fix all of these issues, and it does a pretty decent job. It doesn't get everything every time, but a lot of the times it does really well. So you can see that it has gotten rid of everything but 3. There are 3 areas where there's still problems. So we're better off than we thought we were, but there's still some work to do. And one of the things you'll notice if you zoom in really close is you can see how the individual polygons or triangles on the mesh are kind of jagged and not really naturally appearing. And we're going to go ahead and fix that. It looks like kind of crinkled paper when you look up close. So we'll say we're done, and we're going to go to the next operation, which is a remesh operation. So to do that, go back to Select, and we want to select everything now. So hit Control A, and what that will do is it will select everything. Select all. Control A. So now everything is orange, and we go to Edit here and choose Remesh. And what so here we are, edit remesh, and what remesh will do is it will attempt to replace the entire surface of this model with new polygons and new triangles that are about the same size and about the same density, so that you don't have a lot of really tiny ones and really big ones that give it that jagged crinkled paper type of appearance. So the remesh operation will redo the entire surface of the model, keeping the same geometry and anatomy, but kind of making the surface appear more smooth and natural and less jagged. Unfortunately, this operation takes a pretty long time. On my computer, and I have an 8-core computer with a PC with 16 gigs of RAM, and it takes about 6 or 7 minutes at least. So we're in for a little bit of a wait while it's doing this. But we can go ahead and check on the file that we uploaded to the embodied website in the meantime. So here we go. We'll open up our browser while Meshmixer is working in the background, and look for our file. So what I'm going to do is go to it's probably emailed me a link, so that'll, if I have my email account open, I can just go directly to that link. But if you don't have the link, or you don't have your email account open, which I don't, you can go ahead and just click on your profile and go to your profile, and it'll show you your latest activity. And we can see that the RSNE tutorial intro medium quality that I submitted now has there's another file called RSNE tutorial intro medium quality processed, and that means that that is the process output of this file that I originally submitted. So this should be my processed file. So let's take a look. And there we go. So with only filling in a few parameters, it looks like we've got a pretty decent file. So I'm going to go ahead and download this. You have to agree. And we'll check it out. And again, Meshmixer is still kind of going in the background, and already our uploaded file to the embodied website is done. So that's great. Okay, so here we go. Show in folder. Alright, so this is our file. And let's go ahead and open that one in another Meshmixer window. I guess these other ones I can get rid of. Okay, so here is our new file that Meshmixer, or sorry, the embodied website automatically generated. And this is a pretty complicated file to make on medium quality. Let's go ahead and check it for errors using the inspector. There's one little error which we can probably easily repair, and there we go. And now this file is ready for 3D printing. And you can see that if you look closely, the geometry is very regular. You know, all the polygons are about the same size, which is what you want in your final model. You don't want some polygons to be very small and other ones to be really gigantic. So this is a very even model, and it's pretty good. Medium quality. There are some problems, you know, like around here the jaw looks like the teeth didn't really get a lot of detail, but that's okay. So this is now ready for 3D printing. So we did that in about, how long did that take? We uploaded the file 18 minutes ago, and it was completed 7 minutes ago, so it took 11 minutes to process. So that's pretty good. Now, we don't need to save that. Now, I did actually, before I recorded this video, create a high quality version of this file, which we can download and kind of compare. So that's significantly bigger. That's 136 megabytes. But looks like my internet connection is handling it, and it's downloading it without having us wait too long. Okay. Alright, so this is our high quality file. Let's take a look at that and see if it's any different, other than being larger. And of course, if you go to the embodied website and use this service, you can specify whether you want low, medium, or high quality for your files. The only thing is that the higher the quality that you use, the longer it takes to process the files, and also the bigger the files are. So this is high quality. This is 1.4 million triangles. No, 1.4 million vertices and 2.86 million triangles. So this is a gigantic file, and you can see that the polygon detail is much sharper. I mean, the polygons are a lot smaller, and we can see some really exquisite anatomy here. This is the jugular vein, and underneath that, right under here, is a carotid artery, and here's a carotid artery in the jugular vein. This is the thyroid and the cricoid cartilage and the hyoid bone, the clavicles. Look at this. You can even see the arteries going over the temporal muscles up here, the facial arteries, and the arch of C1 and C2 and the dens. This is just incredible anatomy that you can get out of a CT scan. This isn't even really a particularly high quality CT scan. Here's the subclavian artery right over here. It's called subclavian because it goes underneath the clavicle, and you can see that very clearly. Subclavian artery coming out under here, and here's the scapula. So this is great, and this took about 25 minutes or so to process, but uploading it was basically the same as what we did before. You just, instead of checking medium quality, you check high quality, and then you get an email 25 minutes later. It says your file is done, and this can be 3D printed as well. Look at that. Look, you can even see the arteries as they course over the scalp. That's really incredible. Okay, so our online service has generated our model for us, and that looks great. Let's see how Meshmixer is doing. It looks like Meshmixer is now done with its remesh. So we'll click accept. Come on, Meshmixer. All right. Well, nope, still working. Okay, so here we go. And okay, so we've remeshed it, and you can see that the polygons are a lot more evenly distributed now. It doesn't look like that crinkled paper kind of appearance as much. Okay, so let's go ahead and one of the things that remesh can do is it can help to eliminate any sticky mesh errors that are difficult to get rid of. You can see that we still have some problems down here. So let's go back to analysis and go back to that inspector and see if we can do another auto repair that will fix whatever's left to fix. So we'll go to analysis, inspector. There are still 2 areas of concern. We'll select auto repair, and there you go. We should be good to go, and our model is now done, and it looks pretty good. It looks like they had some of the same problems with the teeth. I think this model may have had some metal artifact in the teeth that made that come out that way, but it doesn't look too bad. So there you have it. 2 separate ways to use free software and services to make medical 3D printable models. You can use the online service at embodied.com, or you can use the desktop way to do it, which is using Meshmixer and 3D Slicer. Both of them are functional, both of them work. The online service is, I think, easier to use and faster. It's not quite as flexible. It doesn't allow you to custom tailor things when you want to get into some really advanced 3D modeling. You can't do that with the online service. But if you just want to easily convert a model, it's pretty quick, and you can also upload multiple models simultaneously. So I use the service, and it's pretty common for me to just upload 10 models all at this, or 10 scans all at the same time, one after another, and the service will automatically process them, and kind of by the time I'm done with uploading the 10th one, the first couple are already completed. And so what that allows me to do is just convert a whole bunch of models very, very quickly. And if you go to the Embodied website, you can see that there are a lot of models available for sharing and for free downloading. You go to the download section, and you can see some really incredible anatomy. So this is a shoulder that was made from a CT scan. Yeah, so all of this is available for download if you're interested in that. You don't want to bother creating your own 3D printable models, but if you want to create your own, you can use the online service or desktop software. So thank you very much for tuning in. I hope you found this video useful. If you did, please click the like button, subscribe. I'll be having many more medical 3D printing tutorials and videos coming out in the future. So please subscribe and help to support the channel. And thank you again, and happy medical 3D printing.